Let's discuss Cosmos gas, adjustments, fees, and prices. Gas is really just a substitute for the word compute. So whenever you think about a transaction taking a lot of compute, that is a lot of gas is required for that transaction to be successful. This is just a standard integer number, typically up from about 100,000, increasing as the request becomes more computationally expensive within that period of the block. So you hear gas, you think compute. The adjustment is the amount of gas that we can sway in the positive side typically. So maybe I know a transaction takes 1,000,000, but just to be sure, I can add a gas adjustment and I could put that as a 1.3, for example, for a 30% increase over 1,000,000. So instead of 1,000,000 gas being able to be spent, we can spend up to 1.3 million because of that adjustment there, in case it is maybe more expensive because more users are interacting with that contract as well, increasing the state size, which thus increases the compute size for that request. The other option is gas fees, which are a hard set value for the amount of gas that you're using. This is kind of confusing because it also mixes with gas prices, which is the price of gas to compute. So fees are the set way of, I know I'm doing 1,000,000 compute and I'm willing to pay, for example, 5,000 U tokens. Now the other side of that could be, I know I'm doing 1,000,000 compute, maybe I'm willing to pay 0.001 U token, and then doing the math on that could increase or decrease based off of that range. So gas prices are going to be better whenever you're using a gas adjustment, and then straight gas with fees is better if you know exactly what you want to spend and what you're willing to spend there. So let's actually run an example. Here I'm going to start a local Juno node that's going to build up the binary and begin to process blocks here. We can then test this with junod status 26657, and we can see indeed that this is on the local 1 node. Just as some information, if you wanted to set that, we can set that as junod node equals that, and now anytime we type in the command here, it would set that. If you need to set it for longer durations, you should do that in your bash file or bash profile, and you can actually set that as an export. That way, anytime you open up your terminal, that is used by default. This could also be a public node. Just make sure to specify HTTPS and port 443 whenever doing that. Okay, so we have a public node set up. We need to run a transaction. This automatically sets up a few accounts here for us that we're going to use to test out gas sending. So let's do a bank send, and we're going to send it from the Juno 1 account. Well, let's actually show this. So we'll do Juno keys list, and we can see here that for Juno 1, we have this FTL address here at the end, and then for this local 2 account, we have this DZK. So we're going to send it from Juno 1 over to the DZK. So what we're going to do is we're going to run junod. We're going to use the transaction subcommand, the bank module, and the send functionality here. This will be done in a future video as well to show more nuances of the different modules and features that are here. That way we can navigate this easier, but for now that's out of scope. What we're going to do is we're going to send that over to this other account here, and then we're going to send some amount. Let's send 123 UJuno. As mentioned in a previous video, UJuno is 1/1,000,000th of a normal Juno based off of the U, which stands for micro, which is 10 to the 6th power. And let's just try to send this. So we're going to automatically say yes to sign it. If we didn't, it will ask for us to do this. So for a yes confirmation, so we're going to submit this, and no fees were specified. So here we're running into an issue where we want to perform an action, but we have not actually specified what fees can be used. So in this case, the fees are set on the validator to be at this micro denomination of 1/4 of a UJuno. So a very small fraction of a UJuno, but this is able to be a fraction because we're multiplying it times the amount of gas. So if I come here and I take this amount, and let's just say that for a rough example, we had 1,000,000 gas. So that'd be 1, 2, 3, 1, 2, 3. We need to provide 2,500 UJuno to actually process this transaction here. But if the gas prices was higher, we can that'd be 3,000 UJuno. But maybe mainnet is much more expensive. Okay, so this is where we can begin to see the amount of gas times the gas price is going to give you this set fee. And because I know that set fee now, based off of the previous example of what the network actually is here, of 2,500, I could then always force through a set fee of, say, 3,000 in this instance, if I wanted to for this transaction. As we can see here, within this, it only wants 500 because it's actually only using 250,000 gas. And we can check that by setting the gas 250,000, 1, 2, 3. And now we can, okay, it's 200,000, yeah. So at 200,000 gas, it knows 500 UGeno is that price based off of what the minimum price should be in that math application there. So we know we need to specify 500. So what happens if we just specify that? So let's set fees equal to 500 UGeno for that amount of gas. We'll submit that through, and it looks like it was successful. So let's do GenoD. We'll query the transaction data, and we can see that there's no errors, and it looks like this did go through. This was successful because we provided enough gas for the amount that we wanted to consume. So what happens if I set $4.99? It should fail because not enough fee was specified. Now what happens if I specify more than enough fee? So I specify 501. I can submit this and the transaction will continue to go through because we had enough to cover the gas. But again, in the event that the gas increases, we no longer have enough in this transaction. So we know set fees now, but maybe we want to make sure that no matter what gas we submit through, for example, if we wanted to do a gas adjustment, we could set gas to equal auto, and then we can set the adjustment to be, let's say 1.3, because we're unsure up to a 30% variability what may happen with gas, and so we want to set that. And so now we can set the gas adjustment to 1.3, and we can see that we don't actually have enough here. We only need 147 UGeno. So before in this transaction we spent 500, but really we only needed 147. So because of the gas adjustment being auto, it knows how much we need to use. We can now specify that in fees, and we can say that we want to only use 147 UGeno. And in this case, because the adjustment is not enough, it actually wants a higher amount. So because it told us in the past, hey, that's enough, but now it's realizing that's actually not enough, we're still going to fail you here. So, okay, we can increase to 202. And then now that's successful. So that's still half as expensive as it would have been before. And we can query that and ensure that the transaction did go through. And indeed it did. So for, over half the price of what we were previously spending on gas by setting it manually, we can use an auto adjustment plus a little bit extra on top of that to ensure that that does go through. As you can see, sometimes it still will fail. So you will have to tinker with this a little bit, and it kind of can become a pain. So we've now adjusted for set gas fees, where we're saying this is what you're going to use and this is what you're going to take out of the account. If I don't have enough, the transaction will fail, and it will also take those fees out of your account. But what if we wanted a more variable based, where you just take it as the application sees fit, where maybe this gas auto is actually like a 5 million gas compute, it would still take that out of your account even though you didn't specify a hard-coded transaction. What we would do here instead is you would use gas prices. So now we know up here that we're using the 0.0025 UGeno, and this is again multiplied times the amount of gas compute that you use. Public nodes typically that do not have this global fee module will not make this public. However, you can normally assume that it is this amount unless otherwise specified in the documentation. You should talk with the chain's Discord in that instance. So we have this 0.0025, and we know that that is the set price at minimum to get into the block from this validator, since we're only wanting one validator. If multiple validators were proposing blocks, they could all have different values here, where maybe one of them requires you to send 1 UGeno per gas cost, which is extremely expensive. And if that's the case, none of your transactions will ever go through until you satisfy that validator who is proposing the block that amount. So because we only have one, we can guarantee in this instance that we can set a gas price of 0 UGeno here, and we can say that that works. Now what happens if I don't specify enough? The transaction fails because we did not send enough to satisfy that. So even though we're not hard coding it anymore, we are at least hard coding the price, so that way in the calculation it can make sure, do you have enough value that you're submitting here for what you're requesting in terms of computation. So if I increase this to 250 million, it will consume all of that fee. It will consume all of that gas, even though we only needed a very small portion of that, roughly 100,000 gas. And so even because of that, this transaction still will go through. That will come out of your account, and there's no way to recoup those. That has already been paid to the network. So in Cosmos, you must pay the minimum, but you can easily way overpay the minimum, and you could, theoretically accidentally spend a large amount of money with fees. So you do need to be careful in terms of not fat fingering a number on your keyboard. But for the most part, there's multiple different ways here where you can set, I only want to spend this amount. I want to spend this amount of gas at this price. I'm going to spend this amount of gas with this amount of fee specifically once that goes through the mempool, and different variations of that to be sure that you get your transactions on chain to perform your actions.